In this topic, we are going to discuss about R to R ladder, digital to analog converter, and it consists of a two kind of a resistance, R and 2R, and in front it consists of an operational amplifier, where in inverting configuration, where at the feedback we have a resistance RF. The 2R arm has a switch in it, and it can be connected either to the ground or to the V reference supply, and it is actually controlled by bit B0 or B1 or B2. It's these bit actually control the connection of the switch. So basically when B is 0, the switch will be connected to the ground, and when B is 1, the switch will be connected to V reference supply. Now let's solve this R2R network for 001 code. Now to solve this, we have to calculate its Thevenin equivalent resistance. And since for our Thevenin resistance, these 2R will be 2R and 2R will be parallel, so equivalent resistance will come out to be R. And the voltage Thevenin that we will calculate, VTH, it will be V reference multiplied with 2R upon 2R plus 2R, and this will be equal to V reference by 2. So equivalent circuit will be V voltage, which is V reference by 2, and resistance, which is R. So equivalent resistance will be again 2R in parallel with 2R, so it will be 2R, and again VTH will be V reference by 2 multiply with 2R upon 4R. So voltage will be V reference by 4. Equivalent circuit will be V reference voltage, which is V reference by 4 and 2R, and then again 2R. So again the voltage, the equivalent resistance will be 2R in parallel with 2R, which is R, and VTH will be V reference by 4 multiplied 2R upon 4R, which will be V reference by 8. So if we draw an equivalent resistance with op amp, then it will be op amp with a feedback resistance RF, and we have a resistance equivalent resistance which come out to be R, and voltage which was V reference by 8. So output voltage will be, for the code corresponding to 001, it will be minus RF upon R, and then voltage which was V reference by 8. Now let's see for the code. If we supply a code 010, okay, in that case now the middle one will connect it to the reference, rest two will be connected to the ground. And again for solving for that, 2R and 2R will be in parallel, so equivalent resistance will be R, so it will again come out to be 2R, then a resistance to R which is connected to supply voltage V reference, and then of course R to R. Now again we can solve using Thevenin equivalent circuit that we have done previously. So again V reference this time will be 2R by upon 4R, which will be V reference by 2, and for the voltage will, and the resistance equivalent resistance will be 2R in parallel with 2R, which again come out to be R. So equivalent resistance would be with the voltage supply VRF by 2, and 2R and again 2R. So if we again do this, the voltage which will be Thevenin equivalent will be V reference by 8, V reference by 4, and resistance will again to parallel in parallel with 2R, again R. So if we represent this solve further, so it's basically again this time resistance again will is R, the voltage V reference by 4, and in feedback we have resistance RF. So the output corresponding to code 010, it will be minus Vref by R into V reference. So it will be minus Vref by R, V reference by 4. Similarly, if we calculate for the code corresponding voltage corresponding to 100, so only the switch which corresponds to code B2 will be connected to the reference, all other will be 0. So equivalent resistance again 2R in parallel with 2R, it will be R. It will again become 2R in parallel with 2R, it will be R. Then we will get again 2R, and then voltage supply V reference. And so if we calculate the equivalent circuit, then V reference will be V reference by 2, and RTH, R Thevenin, will be again come out to be 2R in parallel with 2R, R. So with the op amp, the equivalent resistance again will be R and feedback resistance RF, but the voltage is V reference by 2. So voltage corresponding to when code is 100 is minus RF by R in bracket V reference by 2. So if we write all voltage corresponding to 001, which is minus V RF by R, V reference by 2 to the power 3. Voltage corresponding to code 010 is minus RF by R, V reference upon 2 to the power 2. And voltage corresponding to V100 code V100 is minus RF upon R, V reference by 2, which can be rewritten if we add total. So in general expression will be minus RF upon R, V reference I from 0 to n minus 1, Pi upon 2 to the power n minus 1.